So this is the last part of Lab 12 where we're going to evaluate the results of our Mueller-Hinton plates. So these are the results of my Mueller-Hinton plates. So if you look, this is my shoe plate, and so this creaminess that you see growing is the bacteria. And then these are the three different antibiotic discs that were placed on it prior to allowing the bacteria to grow. And so what you can see is that the bacteria is growing over the entire surface of the plate, but near each of the discs, there is this region where there is no bacteria growing. We call it a zone of inhibition. And so if you look, this circle that I'm doing here is you could measure the diameter of this circle and compare it to the other antibiotic discs. So that has TE on it, so that's tetracycline. This is K for kanamycin, and that is AMP for ampicillin. And so this is one of the plates. This is the second plate. This says skin on it, so this is the bacteria for my skin. So again, you can see the cream-colored bacteria that's growing over most of the surface of the plate. But then near each antibiotic disc, there is a zone of inhibition. Now, the third and final plate is yeast. So yeast are not bacteria, they are eukaryotic fungal organisms, and they are not impacted by antibiotics. So antibiotics are specifically going to target bacterial cells, and so that's indeed what we see in each of these two plates. But in the yeast, the creaminess is the yeast growing over the whole surface of the plate, and they grow right up to the edge of the disc. And so this is known as the Kirby-Bauer test, or the diffusion susceptibility. And what it allows you to do is for a specific bacteria, so again, this is a bacteria from my shoe, you can ask the question, is this bacteria sensitive or resistant to particular antibiotics? And in this case, it's these three antibiotics that we tested, but we could have put more discs on there if we were interested. Now, rather than just eyeballing it, there's actually some quantitation that we can do. And so what I'm going to do is take this plate and show it to you on the next slide. Now I'm zoomed in, so you can still see this is the shoe plate. And now what I've done is I've overlaid a ruler, specifically using the centimeter scale. But more importantly is we actually want to use not centimeters, but millimeters. So that's the unit we want. And so each one of these little marks is 1 millimeter. And so if you add up 10 of those, then you get to 1 centimeter. And so this is 3 centimeters. Oh, so let me pause for a second. What you want to measure is the diameter, so from one edge to another edge of this zone of inhibition. And so that's what we're measuring here. And the units you want to use is in millimeters. And so this is going to be, it's about 29 or 2.9 centimeters. So 29 millimeters is the measurement that we get, and that's from the kanamycin. So right here. So when you look, the way that you use this table is we're asking the question, is this bacteria from my shoe sensitive or resistant? Or there is another category known as intermediate. And so let's just review what each of these means. Sensitive means the bacteria responds to the antibiotic, meaning the antibiotic is effective. And so if we say, oh, this bacteria is sensitive to kanamycin, it means kanamycin works. It kills or inhibits the bacteria. Whereas if we were to say, oh, this bacteria is resistant to kanamycin, it means kanamycin doesn't work. Another way of saying that is the kanamycin has no effect on the bacteria, and the bacteria can grow in its presence. So this is a really important clinical finding. If we say a bacteria is sensitive to a particular antibiotic, then that means that's a usable antibiotic that can be appropriate to treat a particular infection. The flip side of that coin is, if we say a bacteria is resistant to a particular antibiotic, well, that means that antibiotic can't and shouldn't be used because the bacteria can grow in its presence. And so the way that you use this table is you measure the zone of inhibition in millimeters, And then you find the particular antibiotic that we're interested in. So that K is for kanamycin. And this number, you have to find where it falls on the chart. So you have to remember kind of what these mean. So this says greater than or equal to 18, which is where 29 millimeters is. 29 is greater than 18. It's not between 14 and 17, and it's not less than 13. And so the smaller the zone, and this hopefully makes sense, the smaller the zone, that means resistant. The bigger the zone, that means sensitivity. And so this is where we are at. And so we would conclude that this bacteria from the shoe is sensitive to kanamycin. And now I would do this for each of the other antibiotics as well. I would measure this diameter using my ruler all the way across. But now I would compare it to the ampicillin row. And then here's tetracycline. So we would have to go, again, this diameter. So that's how you end this lab. You measure zones of inhibition and then compare it to this table to determine if your bacteria are sensitive, intermediate, or resistant to these 3 different antibiotics that we studied. So to finish up this lab, you're going to want to put on gloves and take a photo of the plates with these zones of inhibition. And then, of course, measure and record all of these zones of inhibitions and put that information into the worksheet. Once you've done that, you're done. And so then you can bleach the plates like you've done in the past and then discard them after the appropriate time. So 20 minutes with bleach, pour that down the drain, and then wrap your plates and then discard.